Hello, continuing our work with circles, we're looking at when circles touch internally or externally. So we're going to look at the two different situations and what their consequences are, and we have to know these consequences by heart. They're not in our log tables. So if two circles are touching internally, so one circle is inside the other circle, and they are touching off of each other here, something to point out here is that they will have one point of contact. So if we were looking for where they intersected, we'd only get one point of contact, and we'd find that they had a common tangent instead of a common chord. But if we're simply asked for the test as to whether they are touching internally or externally, the method that we want to use is the one that we're going to discuss here. And it's purely a graphical argument. We can see our circle here. My blue line is my R1, my radius of circle 1. So I can see my blue line goes all the way out here. This radius 1 goes all the way from the center out to the circle. My radius 2 goes from the center of S2 out to my point of contact of the two circles. If I look at that situation, what is the distance between the center of circle 1 and the center of circle 2? This distance here. Well, it's given by the difference between the radii. This is R1. If I subtract away R2, I'm left with the distance between my two centers. So if the circles are touching internally, then the distance from one center to the other is going to be given by the difference of the radii. We take one radii away from the other, one radius away from the other, and we get the distance between our two centers. So how are we going to put that into practice? If we find the radii of the two circles and then get the distance using our distance formula between the two centers, if that's equal to the difference between the radii, that means that we have circles touching internally. The slightly easier to view situation is when they're touching externally. So again, to remind you, this, if they're touching, it means that they're only touching at one point. That means that there's a single point of contact, which means we'd get repeated roots if we were looking for our intersection between our common tangent. Reminder, we'd subtract our two circle equations away from each other, and we get the equation of this line L, just like we would here. Tangent line L. And it would only cross either of our circles at one point, so it would be a common tangent in both cases. But how to show that you have an internal or external touching is still going to come down to our two arguments here. And again, the argument is going to be, if we look at the distance between C1 and C2, the center of circle 1 and the center of circle 2, it's equal to the sum of the radii. Now, something that's easier to see in this diagram, but is true of this one as well, the centers of the circles and the point of contact, P, are collinear. They're in a straight line. Now, this is a consequence of, you can think about it in lots of different ways, but probably the easiest one to link back to is, we know that if we have a tangent to a circle, the perpendicular at the point of contact goes through the center of the circle. If we have a tangent to a circle, the perpendicular to that tangent at the point of contact P goes through the circle. Well, if they have a common tangent, that means that this line goes through both centers. And this could be important in an exam question. This is true both internally and external touching. It's just easier to see with the external one because it's more spread out. So those are our kind of general discussion points. What we're going to do in practice is find the center of both circles, the radius of both circles, and show that the distance between the centers is either the difference of the radii or the sum of the radii. And if it's neither, it means that they don't touch internally or externally. They aren't tangent to each other. They aren't just touching each other. So let's put this into practice. I have two circles here, and I want to know, do they touch externally? So I'm looking for, does this criteria get met? Is the distance between the centers equal to the sum of the radii? So let's find the centers and the radii. I'm going to recognize immediately that I have the equation of a circle here given in this form. So I'm going to write down that formula and I'm going to use it to get my center in my circle. So my center is at h and k. So C1 is at h and k, which is equal to -3 and 2. Extremely important to write down the formula you are using, or chances of making a mistake with the signs are very high. Or squared is equal to 20. So therefore, or take the square root of both sides, or is equal to the square root of 20. And just for practice, we can recognize that this is 4 times 5, which would give me with 2 root 5. This is an important skill in algebra to be able to break down into surd form. We don't need it here, it's just important in general. And roughly speaking, for drawing a sketch, that is going to be equal to about 4.5. This is for drawing the sketch. Now I have the other equation of my line is kind of given to me in the expanded form, but I recognize that I need to have everything equal 0 for my circle equation. So my first job is going to be rearranging, add 29 to both sides. So it's in the correct form before I try and read any information off. Otherwise, the chances of reading off C as being -29 instead of +29 are very high. So we open up our log tables and we look at what form the equation has to be in, and we are going to write it directly beneath where we're working in order to avoid a mistake. Some of the most common errors in these kind of questions are failing to do the setup properly. So if we get into the habit of doing the setup properly, we're sorted. So G is going to be half the coefficient of the X, which is -3. F is going to be half the coefficient of the Y, which is -5. And C is going to be the constant on the end when we have everything equal to 0. So my center is at G minus F. And that's at 3, 5. And my radius is given by the square root of G squared plus F squared minus C. Is equal to the square root of -3 squared plus -5 squared minus 29. And when I work that out, I get the square root of 5, which for sketching purposes approximately equals 2.25. Now, let's draw a quick sketch of this so that I have a good picture in my head developed of what it is I'm dealing with. So I have a circle. My S1 has a center at -3, 2 and has a radius of approximately 4.5. My center of circle 2 is at 3, 5 and has a radius of about 2.5. So looking then at what I need to include, I need to go to -3, 2. 1, 2, 3. -3, 2. 1, 2. So that's the center of circle 1. And I know that I have a radius of about 4.5. So I'm going to go -3, 1, 2. I'm going to end up somewhere around like that. Sorry. Not a very nice circle in this particular case, but it might be good enough for our purposes. And we need to go to 3, 5 for our other center. So 2, 3, 4, 5, go to 6, and we need to go to 3. And I have my radius in this case is about 2.5, and I know that they're roughly touching. So if I go about 2 in. I know that I should end up with a circle very approximately looking like that. So I'm looking for, I have my radius 1 here. This is S1, S2. Radius 2. This is C2, C1, or 1. So if these circles are touching externally, which is what I'm checking for, and I can see that roughly they are going to based on the very basic sketch, I have the distance from C1 up to C2 must be the same as the sum of OR1 plus OR2. And if I was asked about points of contact or anything like that, my point P would be there, and I would be expecting to have a common tangent between those two. So my L from getting the difference of S1 and S2. But in terms of what I need to do now, I just need to find the distance from C1 to C2 and check that it's the same as OR1 plus OR2. And if it is, then my circles are touching externally. So let's do that. I have C1, C2. Distance from C1 to C2 is what I'm looking for. It's going to be normal distance formula. And I need to write down what C1 and C2 are immediately above where I sub in. C1 and C2 is at 3, 5. So subbing in x1, y1, x2, y2. I get 3 minus 3 to be squared plus 5 minus 2 to be squared. When I work that down, I get the square root of 45, which is 9 by 5, so I end up with 3 root 5. So that's the distance between C1 and C2. That's the distance between the centers. Well, what's OR1 plus OR2? Is C1, C2, distance between the two, equal to OR1 plus OR2. Is that true? So root 3 over 5, sorry, 3 root 5 is equal to OR1 is 2 root 5, and OR2 is root 5. This is a sum of surds. Because the two surds are the same, I'm able to add them together, so I end up with 3 root 5 plus 3 is equal to 3 root 5, which is indeed true. Therefore, S1, S2 touch externally. So that's what we need in terms of checking whether circles touch internally or externally. We must know these facts. And we should also keep in our minds the slightly more advanced stuff as well, that we have a common tangent between circles that are just touching. If we got the intersection of our two circles, we would get a single point of contact, and we know that the centers of our circles and the point of contact lie in a straight line, because if we have the perpendicular at the point of contact, the line that is perpendicular to L through the point of contact must contain the center. As they have a common tangent, the same line goes through C1 and C2 and P. So C1, C2 and P are collinear. They're lying on the same line. And that could theoretically be brought into an exam style question. But key figures for today are sum of our radii for the difference between for the external touching, and the difference of our radii being the same as the distance between our centers for internally touching circles.